right, so let's go ahead and take a look. What people said was that this is a, let's see, we've got, so the best thing to do is just kind of sort out what you've got. So here I have my S bar 1, my S1, and my N1. And I also need to have my X bar 2, and my S2, and my N2. You really want to like write these down somewhere and keep them kind of straight and clear in your notes. So let's see. What was my claim? That they're different, right? Where the males is different from the females. So we're saying that my claim is that mu1 is not the same as mu2.
It's out.
Oh, sorry. It's different. Of course it is. Oh.
It's
When I
early.
start up.
It's 10 minutes early.
Yeah. Oh, it is 10 minutes early. It's going earlier. What's up with that?
It's daylight savings time, but for early time.
Yeah, exactly. That's just wrong. Okay. So, let's see. So, my X bar 1, that's going to be my boys, I guess. And if you want, you can put male and female. You can make them X bar M, SM. You know what I mean? I can make these, male if you want to, if you wanted to, and make these female if you wanted to. So if it helps you keep track of them, that's totally acceptable. Either way, it doesn't matter. All right. So here I'm going to do X bar 1. It's my males. I had sample of 10 males. That's my N. Found the mean is 123. That's my X bar. And standard deviation of 8. Next one is females. There's 8 of them. Sample of 8. That's my N. N is your sample size. X bar is my mean. So 116. And S is 5. What if you don't know these yet? Then just memorize them. You need to practice to know them, but you absolutely need to know them. All right, so then my step 1, H naught is, what's H naught? Always equal. So H naught is colon, that mu1 is equal to mu2. Is that my claim? No, my claim is that they differ. So my claim is going to be H1. That mu1 differs from mu2. Claim actually means I'm going to use the word support later on. Okay? Step 2. Critical value. Draw my picture. This is going to be two-tailed, so don't forget to shade. And it's going to be positive, negative, something. So let's see, this is 2 tails. My degrees of freedom equal the smaller n. I have 2 n's, 10 and 8. Which one's smaller? 8. 8 minus 1, degrees of freedom 7, and my alpha is 0.05. So let's see, 2-tailed, that's the middle row here. And it's going to be 0.05, so the third column, and down to 2.365. 2.365. So it's, oh, yeah, plus or minus. I got that already. So minus 2.365 and positive 2.365. All right, step 3. Need to find my test stat. So it's my mu1 minus mu2, my x bar 1 minus x bar 2 over square root of s1 squared over n1 plus s2 squared over n2. And I'm just going to take the easy way out and calculate that. Oh, actually, it's not that hard, actually, this one, is it? It wasn't. Yeah. So if you do it if you want to do it manually, oh, sorry, I put it there. So if you want to do it manually, you could start from the inside out. So you could just do 5, what is it, 8 squared divided by 10, thank you, plus 5
Divided by 8.
divided by 8, enter, and then raise that to the 0.5 power. That's your denominator. A numerator would be 123 minus 116, and then divide by what I've got up here, 3.086. So 2.268. Or you can do it using the stat test. This is 2 samples, and if you want to know which one, I can just grab your handy dandy yellow sheet and say, okay, I've got 2 means, right? And look over here. There's my test. 2 sample t-test, right? So figure out where you're looking for on your sheet, and it'll tell you which test to use. So 2 sample t-test, right there. So that's t-test. And I have statistics, so it's going to be x bar 1 is?
X bar 1 is 123.
123? S1 is
8.
8. And 1 is 10. And then that should be 116. And 5?
No, it's N is 8 and S.
Oh. S is 5 and N is 8. Yeah. There we go. Okay. Good. And then my claim was not equal to?
This one's all.
Oh, man.
Oh, man.
Okay, no worries. We got one. It'll be fine. We can make it work. No, we'll leave soon enough. Relax. Okay. And then told no, calculate. Bam, 2.268. There's that one as well. So my test stat is 2.268. It goes right in, it barely misses. It's not in the reject range. So it's in the clear, right? So we're not going to reject H naught. Step 4, do not. Oh, thank you. My bad. So it is not in the rejection range. If you kind of look over here, you'll see it just fall short of being in the shaded area. So we are not going to reject H naught. Do not reject H naught. Which means in step 5, yeah, we do not have enough evidence. So not enough evidence to support, oops, I'm getting ahead of myself. Not enough evidence to support claim that weight, right? I was going to put weight of male and female, yeah, babies. I should say newborns, but that's close enough. All right. All right, everybody okay with this part?
Yep.
If you need to take a picture of it, take a picture of it, because I know we kind of bounce back and forth between the screens a little bit. I'm going to pull it down in 5 seconds, so take a picture if you need it now. 5, 4, 3, 2. All right, good. Confidence interval. How do you find it? we're trying to estimate mu1 minus mu2. So you take your x bar 1 minus x bar 2, the difference that you got in your sample, and you add and subtract your error, where this is your error, your critical value, times your standard deviation for 2 sample means. Again, that's how you find it. Now we've covered it. I actually don't care about those at all because I think they're ridiculous. Not ridiculous. I just don't see the value of them. So we're going to skip page 26 as well. So the next question is, do you folks have any lab 5 or 7 questions or any homework questions before I go into a little bit of review? Yeah?
In the lab 5, how should I find the mu and sigma?
Lab 5. Oh, so the mu is you took every value and multiplied by its probability, and you found that in a column. If you add those up, that's your mean. Right? Your weighted mean is you take every x value, multiplied by its probability, and you add them up. So you sum that column. The standard deviation, sigma, is you take, well, the variance is you take every x value squared, multiplied by its probability, and you add those up. That's your variance. And the standard deviation would be the square root of that.
And how should I find the P3?
Oh, right. So if you have a bunch of probabilities, say the probability. So here I have x and probability of x, for example. X is 0, 1, 2, 3, 4, 5. And say this is 0.1, 0.3, 0.2, 0.1, 0.05, 0.05. What's the probability that something is 3 or more?
3, 4, 5.
Greater than or equal to 3. Which ones are greater than or equal to 3?
3, 4, 5.
Yeah, these ones. So we're going to add the probabilities. 0.1 plus 0.05 plus, right? It's equal or greater than 3. It's 3 or 4 or 5. Or as we add, we're going to add them. Done.
Do we need any formula?
It's you just add them. That's it.
Add?
Yeah. So remember, if it's a table, I've just given you the probabilities, right? Yeah. And you just add them up. Okay. Any other questions? Those are good questions. Any other questions for lab 7 or lab 5? Any homework questions? So don't forget for the homework, you will have to, they'll give you a list of numbers and you need to compute the mean and standard deviation on your own. Use S, not sigma, because you know it's a sample. The calculator will give you both. Right? So don't use sigma or else you're going to get it all wrong and you'll spend hours going crazy trying to figure out what you're doing wrong. And it's because you're using sigma instead of S. Right? So if it's a sample, sigma has no meaning. It's meaningless. Only S has value. All right, so study guide. I want to look at questions 1 and 6 today. Question number 6 is really not that important. I just want to again point out the fact that on your homework, you're going to have these columns where you're given a bunch of numbers. Whenever your data is numbers, it's a mean. So you're going to calculate the X bar and the S yourself. Right? So that's all I want to point out for that one. We can look at it again later if you want. But right now, what I want everybody to do is problem number 1 from the study guide, this one here. So I'll give you folks 5 or 6 or 7 minutes and then we'll go over it. The first thing you should be looking at is it a mean or is it a proportion? So give that some thought. Mean or proportion? How do you tell if it's a mean or proportion? Okay, good. Once you figure that out, then figure out if it's a hypothesis test or a confidence interval. How do you figure that out? Sort that out. And the last thing is if it's 2 samples or 1 sample. that bit of information, those things will tell you which area of your yellow sheet to look on. Find your formulas and all the pieces that you need and what to do. Yellow sheet is gold. But it does not tell you what the best point estimate is. You have to write that down in your notes somewhere else. But it will tell you how to do. If you don't know how to find the point estimate, skip A and go on to B. That's fine. Do B and C. Right. So if you don't know A by now, you're not going to know A. Just move on to B and C. All right. So what do we have? We've got the best point estimate. The best one number estimate of mu is what you got from your sample. What's my best? So remember, this is a mean. What's my best guess of the mean? 14.3, my x bar. That's my best guess at what the mean is. Find the margin of error. So my E is equal to my critical value times S over square root of n. My critical value from the table, my degrees of freedom is going to equal n minus 1. So that's 28 minus 1, so it's 27. So what do you get for critical value? 0.052 times S, which is 2 over square root of n. And what did you folks get for your error? 776. Great. All right, and then so then that means that your x bar minus your e, so your x bar plus your e is going to be 14.3 minus 0.776, so 14.3 plus 0.776. That seems really small. We'll go with that. So you end up with 13.524, great, to 15.076. And then we want I said as many as what we had here. So here we gave it with one decimal place. So you should also have one decimal place. So 13.5 to 15.1. Make sure you round correctly. All right, have a great day. I'll see you folks tomorrow.